Good day everyone. So for today's video, we're going to solve a problem solving about a DLV4 and compression. So first problem is we have integrating air side loads with VCC capacity. An air handling unit or AHU process 10,000 CFM of air cooling it from 85 degrees Fahrenheit DVT and 50 degree relative humidity to a saturated state at 50 degrees Fahrenheit. Calculation: determine the total cooling load in tons of refrigeration using the enthalpy difference method. HT is equals to 4.5 times CFM times delta H. VCC analysis in the evaporator is the evaporator compression cycle has refrigerant enthalpy gain of 65 BTU per hour per pound. Calculate the required refrigerant mass flow rate pound per minimum to meet this load. So the solution is we have H1 is equals to 34.62 BTU per pound. H2 is equals to 20.30 BTU per pound. So to solve the QT, we have a formula of 4.5 times CFM times delta H. So plug in the givens. So we have 4.5 times 10,000 times 34.62 minus 20.30. So calculate it so you can get the answer 644,400 BTU per hour. So next is load in tons. So we have a QT 644,400 over 12,000. So divide it. So we have 53.7 TR. And next is MRF. So the formula is QT over delta H. So we have a 644,400 BTU per hour over 65 BTU per pound. So divide it. So we have 9,913.85 TR. Next is MRF 9,913.85 over 60. So divide it. So we can get 165.23 pound per minute. So the next problem is we have efficiency and energy consumption. So a packaged air conditioner has a measured power input of 45 kilowatts while maintaining a cooling capacity of 51.1 tons. Calculation: calculate the system coefficients of performance or COP and its energy efficiency ratio or EAR using the formula COP BTU output over BTU input and EAR equals BTU output over watts input. So the solution is cooling input is equals to 51.1 times 12,000. So we can get the 613,200 BTU per hour. Next is to get the power input. So we have 45 times 1,000. So we can get 45,000 watts. Next is power input. So we have 45 times 3,412.12. So we can get 153,546.3 BTU per hour. So next, to get the COP, we have a formula of BTU output over BTU input. So plug in the given. So we have 613,200 over 45,000. So divide it. So we can get the 13.63 BTU per hour. So lastly, we can to get the new total power. So we have 45 plus 5 kilowatts. So we have 50 kilowatts times 170.607 BTU per hour. So we can get the new COP is equal to 613,200 over 170.607. So divide it, we can get the new COP of 3.66. So the next problem is we have a condenser heat rejection and cooling tower interface. So a water-cooled chiller meets a building load of 150 tons. The compressor requires 12 kilowatts per ton. So calculate the total heat reject at the condenser in BTU per hour. Q condenser is equal to Q evaporator plus W consumption. So the solution is we have a Q evap is equals to 150 times 12,000, so we can get 181,800,000. Then to get the total compressor, we have 150 times 1.2, so multiply it so we can get 180 kilowatts. So next is compressor power in BTU per hour. We have 180 times 3,412.4, so we can get a 6,141,185.2 BTU per hour. So to get the Q condensers, we have a formula Q evap plus W compressor. So we have a 1,800,000 plus 614,185.2, so we can get a 2,414,185.2 BTU per hour. So lastly, so to get the Q condenser, we have a to get the CPM, we have to calculate it with the formula Q condenser is equals to 500 times CPM times delta T. So the Q, plug in the given, we have a Q condenser of 2,414,185.2 is equals to 500 times CPM times 10. So shift solve it, so we can get a CPM is equals to 482.84.